there was some mistake in the structure of the sucrose, so kindly rectify it. It is you can note this is the right structure of alpha D glucose and beta D fructose, HOH at carbon number 1. This is at carbon number 2, OH, H at carbon number 3, 4 and 5. And at beta D fructose you can see here the structure. Kindly note it down. OH, this is beta, that is why OH is above. OH, CH2OH, OH, H, HOH, CH2OH, H. Kindly note it down. The structure which is given in your sucrose, the structure which is given you in your that other book, I think it is the Modern's book is there is mistake in that, so kindly check it and draw this structure which I have drawn here. There is loss of water molecule, and this is the final structure of the sucrose which is formed. This is the glycosidic bond formed after the loss of water molecule. So kindly note this structure. Now next we have is lactose. Next, lactose is formed from the lactose is the disaccharide which is formed from the units glucose and galactose. Glucose and galactose. Now the difference in the structures of glucose and galactose is only this, that in galactose you can see at carbon number 4 OH is on the left hand side. That is the only difference. These are the hemiacetal structures of glucose and galactose. So there is C1C4 linkage between glucose and galactose. This is C1C4 linkage formed after the loss of water molecule. Now we will do, this was the Fischer projection formula. Now we will do Haworth projection formula. So in Haworth projection, before doing that, lactose is present in milk, and on hydrolysis it gives us a unit of glucose and galactose. Now I told you before also, the only difference in the structure of the two is, you can see this on the 4th carbon OH here in the Haworth projection formula, it is above and H is down, means in the line notation or in the Fischer projection formula this OH will be on the left hand side, same as in the case of 3rd carbon in galactose. So this is carbon number 1 of galactose and carbon number 4 of glucose. So there will be loss of a water molecule from here, HO, and there is a glycosidic linkage. We get, this is lactose. This is formed after the loss of water molecule. This is the linkage. This bond is, I have told you also before also, that this bond is called as the glycosidic bond. So this is the structure of the lactose. It contains 2 pyranose units. 2 pyran rings are there in, one is of glucose and another is of galactose. So this glycosidic linkage, it is beta D glycosidic linkage because here in the case of galactose, this is beta at carbon number 4. You can see OH is above and H is down. So at carbon number 4 is beta. So that is why this linkage, it is also, or this bond is also called as beta glycosidic bond. Beta glycosidic bond. Beta glycosidic bond due to the presence of carbon number 4. So we have done 3 disaccharides. There were 3 disaccharides in your syllabus: sucrose, maltose and lactose. So this is the last one, lactose. So if there is any problem, you can ask me. I'll answer you in the video. Thank you.